So, hello students. Today we see some very important problems in stoichiometry. Okay, see the first one. So, the 10 grams of a mixture, calcium carbonate and sodium carbonate on ignition, nothing but heating, suffered a loss in weight of 2.2 grams. We have to find the mass ratio of calcium carbonate and sodium carbonate. Means we have to find in that 10 grams, the initial weight of the mixture is 10 grams. In the 10 grams we have to find what is the amount of calcium carbonate, what is the amount of sodium carbonate. Okay, see, we start the problem. So take the amount of calcium carbonate is just x grams. Okay, so like weight of calcium carbonate, just take as x grams. So if CaCO3 is x grams, then what about weight of sodium carbonate? What is the sodium carbonate weight? It's 10 minus x gram. Okay. Next, it is also given on heating. On ignition, the suffered in the loss of weight is 2.2 grams. So we know the reaction, that is calcium carbonate on ignition forms calcium oxide and carbon dioxide. Okay, so this is solid, so this is only in terms of gas. So here on ignition only calcium carbonate undergoes the reaction, sodium carbonate does not undergoes any decomposition reaction. So that's the key point in this problem. So we are doing the total problem only for the decomposition of calcium carbonate. So even the both are heated, both are ignited, only CaCO3 undergoes the reaction. On the decomposition of CaCO3 we get lime and CO2. Limestone giving lime and CO2. It is only the gaseous state. We know that according to law of conservation of mass, the mass of reactant is exactly equal to the mass of product. But again while there is a loss in its weight means we know if a reaction takes place in a closure vessel, then only law of conservation of mass is applicable. Because some gaseous products are also there. So in open vessels they simply went out during the reaction. Okay, their weight is not calculated. So therefore the loss in the weight is only the loss in the weight of the total weight lo loss ayindi ante, so carbon dioxide gas laga helipindi kabatti loss ayindi weight lo. For example, ikkada form ayina carbon dioxide kuda solid form lo unte neeku enta calcium carbonate తీసుకున్నామో so ante calcium carbonate so ante weight ఉండేది అంటే CaO plus CO2 weight combined చేస్తున్నాం, calcium carbonate weight kuda same ఉండేది. But some loss in the weight is absorbed means the gaseous compound ఉంది కాబట్టి so automatically gas helipindi, it went outside కాబట్టి there is some loss. అంటే ఇప్పుడు మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే the how much gas is evolved outside. ఓకే, ఎందుకంటే CaO ఫామ్ అయిన సాలిడ్ అక్కడే ఉంటుంది కాబట్టి దాంట్లో ఆ CaO ఫామ్ అవడం వల్ల ఏం లాస్ రాదు. వాట్ ఎవర్ ద లాస్ అబ్జర్వ్డ్ ఇన్ ద వెయిట్ is nothing but equal to the weight of CO2 which is went outside during the reaction. So the calcium carbonate, see here how many grams of calcium carbonate. So we don't know how many grams, so but we've taken it as x grams. So according to the reaction, 100 grams calcium carbonate produce carbon dioxide. Why we are taking only carbon dioxide means the weight loss అయ్యే చాయిస్ ఏదైనా ఉందంటే కార్బన్ డైఆక్సైడ్ వల్లనే మనకి due to the releasing of carbon dioxide and went outside, that is only the problem. Okay, produce CO2. How many grams? It's 44 grams. 44 grams of CO2. And how many grams of calcium? How many grams of calcium carbonate is there? X gram calcium carbonate produce how much CO2? So that is X into 44. So the amount of the CO2 released, how much? X into 44 by 100 grams of CO2. Here total loss, here main important point, the total loss in the weight. Total loss in the weight is equal to the weight of carbon dioxide formed. Okay. So it's given a loss in weight is given how much? In the problem it is given 2.2 grams. So therefore here we can say in the place of this X into 44 by 100. This is the loss in the weight of CO2. Nothing but formed CO2 is equal to how much? 2.2. So therefore X equals how much? Okay, this is 22. It comes to 5 grams. So there are 5 grams of calcium carbonate. Okay. Sorry, here how much it is formed? So X equals 5 grams means nothing but weight of calcium carbonate is 5 grams. So then what about therefore weight of sodium carbonate 10 minus X, that is also 5 grams. So what we have to find out? We have to find out the ratio. We have to find ratio of weight. Okay. Weight of calcium carbonate by weight of sodium carbonate 5 grams, so that is equal to, they are in 1:1 ratio by weight. Okay, just here the main key points are the sodium on ignition, sodium carbonate does not reacting. Okay, next, and the calcium carbonate ignition, it is giving calcium oxide, that is solid, so there is no loss. But the formation of CO2 in terms of gaseous state, in the physical state, that is a gaseous state, that is the loss. Means whatever the carbon dioxide formed, that is equal to the loss in the weight. Okay. Okay, see the second question. So here 70 grams of a sample of magnesite. So in these problems we have to remember about the formulas also. The magnesite is a mineral of magnesium, that is MgCO3. Okay, magnesite on treatment with excess HCl given 11.2 liters of carbon dioxide at STP. So find the percentage purity of the sample. We have to find the purity of that magnesite. So why separately purity means we know it is a mineral, so it is having just some percentage of the compound. It is having many number of impurities also. So how to find the what is the percentage purity of that compound with the help of a given reaction. What is the reaction given? So the reaction of a magnesite with HCl releasing CO2 is the clue. Means we have to know this formula and also we have to know the reaction about this. Okay, means just remember in stoichiometric problems we have to remember the different formulas, different reactions. Okay, it's a compulsory, we have to remember, there is no separate technique is there. So what is the reaction when magnesite reacts with HCl. So there is a formation of magnesium chloride, carbon dioxide, H2, and in this problem we have to balance the reactions also. Okay, so 2 chlorines, 2 hydrogens, 3 carbons, sorry, 1 carbon, 1 magnesium, 2 hydrogens, 3 oxygen, 3 oxygens. So now compare magnesium carbonate and about the CO2, because the sample is given about the magnesite, so about the carbon dioxide. So what is the moles relation? 1 mole of calcium magnesium carbonate. Magnesium carbonate nothing but present in the magnesite. It also releases 1 mole of carbon dioxide. So it is given in terms of mass. It is given in terms of liter. So according to this equation, we can say 84 grams of magnesite, nothing but MgCO3, releases how much CO2? 1 mole. It is in terms of volume. It's covered 22.4 liter of carbon dioxide. So here, how much carbon dioxide is produced? 11.2 liter. How much sample is taken? 70 grams. So 11.2 liter base తీసుకొని problem చేయాలా, 70 grams తీసుకొని problem చేయాలంటే we have to take about the product, because we have to check the purity అంటే so nothing but it is not 100% purity. So perfect purity కాదు. సో పర్ఫెక్ట్ ప్యూరిటీ కానప్పుడు అది పర్ఫెక్ట్ అమౌంట్ కూడా రాదు. కాబట్టి రిలీజ్ అయిన ప్రోడక్ట్ బేస్ చేసుకొని మనం ప్రాబ్లం చేయాలి. ఓకే, సో హియర్ హౌ మచ్ CO2 is produced? 11.2 liters of CO2 is produced by how much can be produced by how much CaCO3? So 11 point, so exactly half. So that is so 42 grams of MgCO3 is required. Means just 11.2 liters of CO2 release avadడానికి 42 grams of magnesite MgCO3 సరిపోతుంది. But how much it is taken? It is taken 72 grams. So then what about the remaining impurities? So this is 42, 70. Okay, means the remaining 28 grams for impurities. We have to find the we have not to find out them about the impurities. We have to find the purity of. అంటే మనం 70 grams ఆఫ్ మాగ్నసైట్ తీసుకుంటే దాంట్లో MgCO3 ఎంత పర్సెంటేజ్ ఉందంటే, సో ఎంత అమౌంట్ ఉందంటే 70 grams లో జస్ట్ 42 grams రియాక్ట్ అయింది. సో యాక్చువల్గా 70 grams కి 70 grams రియాక్ట్ అవ్వాలి ఇఫ్ ఇట్ ఈస్ 100% ప్యూర్. సో మినరల్ కాబట్టి ఇట్ ఈస్ కంపల్సరీ ఇట్ హ్యావింగ్ సమ్ ఇంప్యూరిటీస్. 70 grams మాగ్నసైట్ తీసుకుంటే దాంట్లో హౌ మచ్ MgCO3 is present? The original mineral is present only just 42 grams. దీన్ని మనం పర్సెంటేజ్ లో కన్వర్ట్ చేయాలి. ఓకే, సో ద టోటల్ మాస్ is given. So just take it as a case 2. Okay, total sample is how much? 70 grams. Reacted is how much? Just 42 grams, means remaining is impurity. So therefore percentage purity equals reacted by total mass. Okay, so on this final calculation we will get approximately, so on this we will get okay, this is so the percentage purity equal to 60%, means it is only 60% pure. 40% of the mineral is having impurities. Impurities means other than required compound, all are known as impurities. Okay. Okay, see the question number 3. So here given that so 1 liter of a mixture of carbon monoxide and carbon dioxide, it passed over red hot coke. Coke means nothing but so carbon present in the red means very hot condition. So the volume, here the clue is given, the volume increased to 1.6 liters under the same conditions. So find the percentage composition of CO and CO2. Here again in these problems, so in this mixture of problems, so I have to remember, so which compound is reacting. So sometimes both compounds reacts. Many times, the maximum times in the mixture only one component undergoes the reaction. We have to find that. Okay, so here the carbon monoxide, carbon dioxide, here, so when it is reacted with the red hot coke, only the carbon dioxide undergoes the reaction. This carbon dioxide combines with the red hot coke and its formation of carbon monoxide. When the carbon monoxide is a gas, CO2 is a gas, formed CO is a gas. So here CO does not react. Okay. CO does not undergoes reaction. Only CO2 undergoes reaction. So at first let volume of CO2. Volume of CO2 is take X. Okay. So then, so how much value of carbon monoxide will form? 2x. Okay. The total we are taking liters covered. Just take X liters. Volume of carbon dioxide is X liters. So how much carbon monoxide is produced here? 2x liter. 2x liter of carbon monoxide is formed in the reaction. Now see, so then the volume. So initial volume of carbon monoxide, how much? It's a very important step. So initial value of carbon monoxide is how much? 1 minus X liter. How it is means, sir? So the initial volume of carbon dioxide we taken X liters. So total is 1 liter akkada. Manam X liters of carbon dioxide తీసుకున్నాం. అది only react అవుతుంది కాబట్టి మనం carbon dioxide X liters of carbon dioxide తీసుకుంటే what is the volume of carbon monoxide? That is 1 minus X liters. Next, ఈ X liters of carbon dioxide react అయితే ఎంత carbon monoxide form అయింది? 2x liters of carbon monoxide. అంటే total after the final volume of so we can't say it's a final volume. Volume of CO, volume of carbon monoxide produced equal to how much? 2x liters. అంటే CO reaction లో participate అవ్వలేదు కాబట్టి so 1 minus x liters of carbon monoxide starting అట్లే ఉంది. CO2 reaction లో ఇన్వాల్వ్ అయింది కాబట్టి 2x liters of carbon monoxide form అయింది. So total increase in the volume. So increase in the volume is how much? That is 1.6 liters. Okay. Sorry, total not increase. The volume is increased from 1 liter to 1.6 liters. అంటే రియాక్షన్ మొత్తం కంప్లీట్ అయిపోయిన తర్వాత దాని వాల్యూమ్ ఎంత అయిందంటే 1.6 లీటర్ అయింది. 1.6 లీటర్ ఇంక్రీజ్ అవ్వడం కాదు, ఇట్ ఈస్ ఇంక్రీజ్డ్ ఫ్రమ్ 1 to 1.6. స్టార్టింగ్ 1 లీటర్ ఉంది, రియాక్షన్ మొత్తం కంప్లీట్ అయిన తర్వాత 1.6 అయింది. రియాక్షన్ మొత్తం కంప్లీట్ అయిపోయిన తర్వాత దాంట్లో ఉండే కాంపౌండ్స్ ఏంటి కదా, స్టార్టింగ్ తీసుకున్న మిక్చర్లో రియాక్ట్ అవ్వకుండా ఉన్న కార్బన్ మోనాక్సైడ్ ప్లస్ కార్బన్ డైఆక్సైడ్ రియాక్షన్లో ఎవాల్వ్ అయిన carbon monoxide. These two are remained after the completion of reaction. So now what is we have to find the composition. So therefore what is given? Given finally value increased to 1.6 liters. So therefore 1 minus x plus this 2x equal to 1.6. So 1 plus x equal 1.6. So x equals 0.6 liters. Okay. So x equal to, we got 0.6 liters means volume of. So therefore volume of CO2 is equal to 0.6 liter and volume of CO is 1 minus 0.6, that is 0.4 liters. It is initial. In initial mixture, like, so what is the percentage means? So therefore percentage of carbon dioxide equals 0.6, total 1 liter, that is 60%. So what is the percentage of carbon monoxide? So that is equal to 0.4, total 1 liter. So that is equal 40%. So here 40% of carbon monoxide, 60% of carbon dioxide is there. So the mixture of these components problem is very important in stoichiometry. Okay, let's see the next one. So the fourth problem, the 25.5 grams of hydrogen peroxide solution on decomposition given 1.68 liter of oxygen at a stage. So what is the percentage strength of hydrogen peroxide by weight? So here we know the hydrogen peroxide is unstable liquid. It easily decomposes giving water and oxygen. Okay, and we also know to check the purity of hydrogen peroxide, we see the amount of amount of oxygen, nothing but volume of the oxygen formed in the decomposition reaction. The oxygen formed in that reaction is tells about the purity of that hydrogen peroxide sample. So first see the reaction. So we must know the reaction of decomposition reaction of hydrogen peroxide gives H2 and oxygen. So here make it balance. So here we have to compare the hydrogen peroxide and oxygen. So here 2 moles and so I think it is not balanced. Here we have to put the 2. So here 2 moles of hydrogen peroxide produces 1 mole of oxygen. So it is given in terms of liters, it is given in terms of mass. So we are converting into mass. 2 into its molecular weight 34. 2 into 34 grams of hydrogen peroxide. So produce how much oxygen according to the balanced equation? 1 mole means 22.4 liter of oxygen. But in the problem it is given, it produced a 1.68 liter of oxygen. So again exactly third problem model. So here we are checking about the products. Because మనం తీసుకున్న కాంపౌండ్ మాక్సిమం 100% ప్యూరిటీ వచ్చే ఛాయిస్ లేదు కాబట్టి ప్రోడక్ట్ బేస్ చేసుకుని మనం కాంపౌండ్ ప్యూరిటీ చెక్ చేయాలి. సో కాబట్టి గివ్ ద ఇంపార్టెన్స్ టు ద ప్రోడక్ట్. 1.68 liter of oxygen is produced by how much hydrogen peroxide? So actually 25.5 grams of hydrogen peroxide is given, but it may contain some of the impurities, unwanted compounds are there. Adi manam find out cheyali kabatti. So product enta 1.68 liter of oxygen. With the help of this 1.68 liter of oxygen, idi produce cheyadaniki how much hydrogen peroxide is required? We calculated with this equation. 1 cross multiplication. and 4. So one overall. So 1.60. So again on this overall calculation we will get just 5.1 grams. 5.1 grams of hydrogen peroxide is required. Means to produce 1.68 liter of oxygen, only 5.1 grams of hydrogen peroxide is required according to the standard equation. But how much hydrogen peroxide they took? 25.5 grams. అంటే 25.5 grams of తీసుకుంటే యాక్చువల్గా చాలా ఆక్సిజన్ రిలీజ్ అవ్వాలి if it is a perfect purity. But it release only 1.68. 1.68 కి యాక్చువల్గా మనకి just 5.1 grams hydrogen peroxide సరిపోతుంది. Remaining మొత్తం it is a impurity. So now we check the percentage strength. So the given sample of hydrogen peroxide is 25.5 grams, but to produce 1.68 liter of oxygen, only 5.1 gram hydrogen peroxide is required. So these are the main point we have to remember here. So here only 5.1 grams required, but what is the remaining? Remaining is important. It is impurity. So therefore percentage strength of hydrogen peroxide sample. So only 5.1 given in 25.5. Means how much used? 5.1 only it is used. Okay, so totally we will get how much here? 5. Exactly comes 0.2. So is equal to 20%. Means that is a 20% by weight of hydrogen peroxide. So see the nearly same problem. So here 60 grams of calcium carbonate on heating produced 22 grams of CO2. What is the percentage of CaCO3 in the limestone sample? So limestone means nothing but actually calcium carbonate sample. So it is also mineral of calcium carbonate or nothing but mineral of calcium. Okay, so means limestone is also having some other impurities. We have to find it. So for checking the purity, it is given the 22 grams of carbon dioxide is released. So calcium carbonate on heating, we know the products are CaO and CO2. So here, so at first according to the equation, this is 1 mole of calcium carbonate produces 1 mole of carbon dioxide. Means so here calcium carbonate given in terms of grams, CO2 also given in terms of grams. So here 100 grams of calcium carbonate on heating produced according to this equation. 100 gram produced 1 mole carbon dioxide means 44 grams of CO2. But here the clue is given. How much carbon dioxide is produced? 22 grams. How much calcium carbonate is taken? 60 grams. For doing problem, we know that to check the purity always we have to take the product. Okay, because reactant lo there may be impurity is there, but forming a product lo no impurity are present. So here 22 grams of CO2 can be produced by how much calcium carbonate? Exactly half. Okay, So that is equal to how much? 50 grams. So 50 grams of calcium carbonate is required. But how much? In reaction, how much it takes place? 60 grams. And just 50 grams toni 22 grams of carbon dioxide release avvadaniki how much calcium carbonate required? 50 grams is sufficient. But they took in the reaction it took 60 grams. But what about the 10 grams means the 10 grams is unwanted compounds. Unwanted compounds here treated as impurities. So therefore here we can write a statement. So the writing the statement is also very important. So the given sample is given sample of calcium carbonate is 60 grams. But only 50 grams of CaCO3 is used. Nothing but is reacted. Means what about other thing unreacted, and therefore unreacted remaining compounds are impurities. So therefore the percentage of calcium carbonate in the given sample is 50 grams present in 60 grams. And 60 grams of calcium carbonate compound తీసుకుంటే 50 grams of perfect calcium carbonate on the remaining unwanted materials are there. Okay, so how much percentage we will get approximately? So here we are getting 83. Okay, so 83.3 percentage. The purity of the compound is 83.33% we are getting. Okay, you see the next one. So it is given 18.4 grams of calcium carbonate and magnesium carbonate on heating, given just 4 grams of magnesium oxide. So the volume of CO2 produced in the total process. So here it's a very important. So in all these so మనం ఇప్పటిదాకా చేసిన problems లో 2 compounds mixture ఇస్తే only one of the reactants reaction లో participate అయ్యింది. So we have to identify it, we have to remember it, which is undergoes reaction and which does not undergoes into the reaction. But in this problem actually both compounds undergoes the reaction. Okay, so with the help of a simple technique we calculate it. So first see the both reactions. So we know that on heating calcium carbonate gives calcium oxide and carbon dioxide. Magnesium carbonate is also forms MgO and CO2. So we know this reaction. So here information is given only about the magnesium oxide which is formed. How much it is formed? 4 grams of magnesium oxide is formed. So how much the total compound is? 18.4 grams. So here the given clues are about MgO, and MgO is formed by nothing but MgCO3. So in the standard equation, so it is total in terms of grams lo undi kabatti, so MgO according to the standard equation here it is how much? 84 grams. So if you find this molecule we will get it. So 84 grams of MgCO3 on heating produce how much MgO general in this problem? This is 24, it's a 40 grams. Okay, so we will get 40 grams of MgO. But here how much you produce in the problem? Just 4 grams. 4 grams of MgO produced by how much MgCO3? Okay, so it is exactly by 10. So here we will get how much? 8.4 grams of MgCO. Means now you got how much MgCO3? 8.4 grams of MgCO3. So after getting 8.4 grams of MgCO3, we are able to know the amount of CaCO3 also. So now take it as a case 2. The total compound is how much? It is how much it is given? 18.4 grams. So therefore means MgCO3. So calcium carbonate is 18.4 grams. Then what about weight of calcium carbonate? Means the weight of calcium carbonate is how much? 10 grams. Okay. Means in the sample we got 10 grams of calcium carbonate, 8.4 grams of magnesium carbonate. Okay. So ippadaaka chesta problems lo ikkada varake unde. Ee step work it's complete. We find the percentages. But here we have to find both undergoes the reaction, both releases the carbon dioxide. So what is the volume of the carbon dioxide released in the total reaction? So again we do it separately, because both compounds are releases different amounts of carbon dioxide. So first we see about calcium carbonate. So calcium carbonate gives again CaO plus CO2. So 1 mole, 1 mole. So 100 grams produce. Here 100 gram produces how much CO2? So carbon dioxide is in terms of liters also. So 100 gram calcium carbonate produce 1 mole, that is 22.4 liter of CO2. Then how much calcium carbonate do we have? Just 10 grams. So 10 gram release how much? So exactly by 10 again. So you will get 2.24 gram. Okay. 2.24 grams of CO2. Next, about MgCO3. MgCO3 also releases CO2. So what is MgCO3 step? Just take it as a step 4. Okay. Just to overcome the confusion, we are writing the steps. Okay. MgCO3, here CO2. So again here MgCO3 84 gram. 84 gram MgCO3 produce 22.4 liter of CO2. Here how much you got? Just 8.4 grams of MgCO3 produce how much? So again it is also by 10. So by 10. 2.24 grams. Sorry, I think it's liters, not the grams. So by 10 here also we get 2.24 liter of CO2. In both processes, they are getting 2.24 liter of CO2, 2.24 liter of CO2. Therefore, what is the total volume of CO2 released? So take the step 5. Total volume of CO2 reduced equal 2.24 plus 2.25. Actually, these both are separately released by MgCO3 and CaCO3. Say 4.48 liters of CO2 produced in the total process. See the question number 7. So in the worksheet, so that is a mixture of sodium carbonate, sodium hydrogen carbonate. The total weight is given 100 grams. On heating produce just 11.2 liter of CO2. So again here the mixture problems. So here important thing is, so here the mixture of sodium carbonate, sodium hydrogen carbonate. So here, so we know that only sodium hydrogen carbonate releases CO2. Already this type of problem we done in this worksheet. Already we done it. So again we do. So just take the weight of sodium hydrogen carbonate. Just take the sodium hydrogen carbonate weight equal just x gram. Then what about weight of sodium carbonate equal to the total 100 grams? Obviously it is 100 minus x gram. So we know that on heating only this undergoes the reaction. This is not sodium carbonate does not give any carbon dioxide. Only it releases carbon dioxide. What is that relation? The reaction sodium hydrogen carbonate. We must remember these reactions: carbon dioxide and H2O. So attempt this standard equation. So here it is 2 moles. 2 moles of sodium hydrogen carbonate gives it is in terms of mass. It is in terms of liters. Attempt the standard equation. So its molecular weight we will get 84. 2 into 84 grams of sodium hydrogen carbonate produce 22.4 liter of CO2 according to the standard equation at STP. We know that. But what about here? Only 11.2 liter of CO2 is produced. 11.2 liter of CO2 produced by how much sodium hydrogen carbonate? So here we get 84. 4, 2, it's cancelled. So here we get 84 grams. 84 grams of sodium hydrogen carbonate is present. So in the mixtures, in the 100 grams, 84 grams of sodium hydrogen carbonate is present. Then what I actually in the problem we have to find the Ne2CO3. So therefore here, the weight of sodium carbonate equal to 100 minus 84. So that is only we will get 64 grams. Actually in the problem the question is about sodium carbonate. So here we got the amount this one. So it is 16 grams. So therefore, so in 100 it is present means 16 percentage of Ne2CO3, 84 percentage of sodium hydrogen carbonate. So all it is given in terms of 100 gravity. Directly we write the percentages. Means in the mixture 16% of sodium carbonate, 84 percentage of sodium hydrogen carbonate are present. Means here we have to remember in the mixture which undergoes reaction and which does not. Okay. Okay, see the next question. So it is given a gaseous mixture of acetylene. So acetylene formula is C2H2 and carbon dioxide. So it is given 20 liters of this mixture requires 20 liters of oxygen. Again means this total mixture requires 20 liters of oxygen under the same conditions for its complete combustion. So combustion means nothing but the reaction oxidation, the complete oxidation of the compound, the total burning of the compound in the excess air is called combustion. Okay, means in the combustion reaction an element or a compound undergoes complete oxidation. So we have to find the percentage of acetylene in the mixture. So here we have to remember, so the mixture contains acetylene and carbon dioxide. So it's the carbon is having the two type of oxides, carbon monoxide, carbon dioxide. So carbon monoxide when combustion cheste, it may becomes carbon dioxide, it may be oxidized to carbon dioxide. But already it is given carbon dioxide, there is no further oxidation of that carbon. So maximum oxidation state into the carbon dioxide. Now there is no further oxidation in it. Means now it undergoes whatever the oxygen required for the combustion is only for the combustion of acetylene. So therefore, here you can say CO2 does not involve in the combustion. So only CO2, only acetylene involves in the combustion. So to gives, we know that any hydrocarbon combustion produces carbon dioxide and water. 2 moles of carbon, 2 moles, 2 hydrogens. So just here 5/2 moles of oxygen is required for the combustion of 1 mole of acetylene. So here it is given 20 liters. So 20 liters is containing again acetylene and carbon dioxide. Okay. So here how much oxygen required? 5/2 moles means 5/2 into 22.4 liters of oxygen. It is also given in terms of liters. Acetylene CO2 also given in terms of liters. So here complete combustion avudani ichindi. So complete combustion ki manaki enta how much oxygen required find out cheyali. Okay. 20 liters of oxygen is required. So all it is given. So 20 liters of oxygen use ayipoyindante. So how much acetylene is present? We can find out easily with the help of this relation. The C2H2 5/2 oxygen moles reaction tone we are able to find the volume of acetylene. Here we can say with the help of this reaction 5/2 moles kabatti 5/2 into 22.4 liters of oxygen is required for 22. This is also 1 mole. So 22.4 liters of acetylene for its complete combustion. Then what about how much oxygen was supplied? 20 liters. 20 liters of oxygen required for how many liters of acetylene? Means ఇక్కడ మనకు ఆక్సిజన్ ఇన్ఫర్మేషన్ ఇచ్చిండు. మనకు బస్ జస్ట్ మనకు ఐడియా ఉండాల్సింది ఏంటంటే ఆక్సిజన్ వాట్ ఎవర్ ద ఆక్సిజన్ ఈజ్ యూజ్డ్ it is done by only acetylene. Because CO2 does not involve in any further oxidation. So 20 liters gives how much? 20 liters reacts with the how much acetylene? So that is just we are getting 8 liters. Okay, so 20 liters need only 8 liters of acetylene. Is reacted. Means it contain 8 liters in the total. It is given how much? 20 liters. Okay. So in the problem it is given 20 liters. Right? In the 20 liters of oxygen, 20 liters of oxygen used in how much acetylene is there? 8 liters of acetylene is there. So 8 liters of ester, therefore in the mixture of C2H2 plus and CO2 of total 20 liters, 8 liters of C2H2 is present. Then what about carbon dioxide? How much carbon dioxide is present? So therefore here 12 liters of carbon dioxide is present, total 20 liters. So it is given, I think in the question it is asked in terms of percentage. So you have to find the percentage. Okay. So I will give the information. So what is the percentage of acetylene? Acetylene percentage total 8 grams in total 20 grams. That is equal to 40%, and percentage of CO2 equal to how much? Automatically 60%. Okay. So you have to practice the problems so many times. I can't say that's just 2 or 3 times. You have to practice these problems at least so till you get the correct answers. Okay.